In the last segment, we talked about molality, and molality is a concentration units that we often use with colligative properties such as boiling point elevation and freezing point depression. At the end of the day, these are a function of the number of particles, and we looked at molecules and tried to determine how many particles we would get out of this. This one is not ionic, so I would be 1. Magnesium hydroxide is only partially soluble, so I would be 1 point something. And we can quantitate that, but it's not within the scope of what we're doing for this course. Ammonium hydroxide is completely soluble, so our I would be 2. And if we're just looking at which one would be most effective at boiling point elevation or freezing point depression, it would be this one. Segment 12 now moves along into osmosis. Osmosis is the movement of water, not particles. And water will move to where there are more particles. So in our picture over here, we have more particles on the right-hand side. So over time, the water will move to the particles, and we will get a disproportionate amount of water on this side. Okay? Osmotic pressure is the pressure exerted by the number of particles. The more particles, the greater the osmotic pressure. Now, physiologically speaking, we want to keep the water balanced with the number of dissolved particles. And this has to do with something that we call tonicity. And tonicity is the number of particles dissolved in solution. So isotonic, iso is a prefix that means same. So isotonic means that we have the same number of particles as a reference. Hypo means we have fewer particles than the reference. Hypertonic means we have more particles than the reference. So in this picture up here, if this is the reference, then this side is hypertonic because there's more particles. If this is the reference, this side is hypotonic because there are no particles. Okay, so for example, if physiological saline is 0.9% sodium chloride, then 9% is, okay, so we have 0.90 and 9.0. I'm adding some digits, so sorry. This is the reference. This one is hypertonic, which means that over time, water will move to the right, which means the right-hand side will take on water. Page 26. If a reference glucose solution is 0.15% mass by volume, a different solution with 1.30 grams of glucose in 2.50 milliliters is, well, what we need to do is to figure out the percent. So 1.30 grams over 250 milliliters times 100%, get out your calculator, is 0.52%. Okay, so we have our chamber, we have our semi-permeable membrane, 0.15, 0.52. If this one is the reference, then this one is hypertonic. And water will move to where the particles are. So over time, this side will take on water. Okay? Now, why do we care? Well, if we have red blood cells, for example, we want our red blood cells to be normal and happy. So if we have our red blood cell, 0.90% saline, in isotonic solution, 0.90% saline solution, the net water in and the net water out will be equivalent. And therefore, the red blood cells remain happy and healthy in solution. On the other hand, if we put them in hypotonic solution, that means the water will move into the red blood cell. Okay, so again, our red blood cell is 0.90% saline. Our solution is less than 0.90%. So the red blood cell will take on water. And this will cause a condition called hemolysis. And our red blood cells will take on water and they will burst. We can also take our red blood cell and we can put it in hypertonic solution, more than 0.90%. In this instance, the water will move out of the red blood cell into the hypertonic solution and we get a red blood cell raisin. We call that crenation. Red blood cell does not live very long. Again, it should be apparent why this is useful. Having water balance in the body and particularly in the blood should be very obvious why that is useful and essential. Okay, so a couple of application questions. You are an EMT and you try to be a good Samaritan. A person is injured and your ambulance is out of normal saline. You consider starting an IV with distilled water. Liabilities aside, is this a good idea? Your red blood cell, 0.90, our distilled water is 0%. Water will move into the red blood cell. So no, distilled water is hypotonic to the red blood cell. Hemolysis will occur. You are a new EMT and you have a new partner. A person is injured and your partner says, 0.9%, 9%, only 1 decimal. I got partial credit in my other classes. This is okay. Let's go ahead and start an IV with that. Hopefully you're laughing at this as you're hearing it. 0.90, 9.0, water moves to salt. So this is absolutely no. 9.0% is hypertonic. And you will have crenation. Very bad news. Okay? The last segment will be a recap of the entire unit, which will discuss the solid state, and this will be very short.